Hi, my name is Dean Sprage. I'm CEO and owner of Nautilus Commercial Fitness. I'd like to talk to you a little bit about Nautilus biomechanics. We have over 24 patents on our strength machines, and all of them are there for a reason. Arthur Jones designed the machines to have form follow function, and we still ascribe to that mentality now today. And what I'd like to do is explain how that mentality manifests itself in our machines. One is there are two basic movements we can do when exercising on a machine. One is a rotary pattern, where we're using a single joint like a biceps curl or leg extension. And the other are compound complex movements, where we have several joints involved and sometimes several groups of musculature. The two require a different variable resistance to achieve the results that we want, namely occlusion or prohibiting oxygenated blood from getting into the muscle, getting to a lactate level, and eliciting muscle growth and capillary density growth. So I'd like to explain to you how we accomplish that on our machines and how we're unique in the industry in doing so. First of all, let's look at how force manifests itself. As I mentioned before, in a rotary pattern movement like a biceps curl or a leg extension, typically this is force, this is range of motion. You're typically weak, you get stronger, and then you get weak towards terminal extension. So biceps curl, I'm weak, my mechanical advantage increases here where I get more muscle mass involved, and then I'm weak again at the end of the range of motion. It's different when we do compound complex movements like a leg press or a chest press, because typically I'm weak to begin with, and then I get stronger as the flexion of the main joint involved is reduced. So let's use chest press as an example. A high degree of elbow flexion, this is where you're weakest in a bench press. And as your elbow flexion decreases, your mechanical advantage increases and you're able to exhibit more force. Now, if I have a linear resistance system, like isotonic weights, it doesn't accommodate to those force outputs through the range of motion. So what I'm trying to achieve again is occlusion of oxygenated blood. And in order to do that, I've got to have at least 40% of that muscle fiber recruited through the entire range of motion. If I don't occlude that muscle appropriately, and I don't elicit the physiological effect, which again is hypertrophy or growth of the muscle and increased capillary density. Same is true on a compound complex movement. If this is as strong as I am at high degree of elbow flexion, then if it's an isotonic or static weight as opposed to our variable resistance, then I'm going to underload the musculature through most of the range of motion and probably not achieve the desired results. To demonstrate that, I'd like to show you our 4-bar linkage on our chest press. The 4-bar linkage, we have 1, 2, 3, 4, accomplishes what we're just discussing here on this compound complex movement. You start off with less resistance at high degree of elbow flexion, and then as elbow flexion decreases, the load increases. And those of you who have lifted isotonically, you know when you're lifting Olympically, this is your weakest point. Many times you have to cheat or become ballistic or have somebody spot you, whereas as your elbow flexion decreases, you get much stronger. How we demonstrate that is I use a hand dynamometer. A hand dynamometer is a force gauge, pretty finite force gauge that's typically used in rehab to measure hand strength, but it also will show you the force required to move an object through a range of motion. And a good demonstration of our biomechanics would include the hand dynamometer, which shows at the beginning part of the range of motion, where I'm weakest, I have less resistance, and as elbow flexion decreases and my mechanical advantage increases, the machine creates more resistance. So what that equates to is a linear occlusion of the muscle through the entire range of motion. That way it protects my shoulder in this particular exercise at high degree of elbow flexion, yet it maximally stresses the pectoral musculatures at extension. This way we achieve the best results with the least chance of injury.